inverse of addition is represented by, that one is B. So this is a repeat question that is frequent in almost every year's paper.
(2014)?
Yeah, this is 2014.
Okay.
All right, so 2014, it says in the real number system, the inverse of addition is represented by, that is x plus minus x. So x is the number, 0 is the identity, and so minus x is the additive inverse of x. And so x plus minus x equals 0. That is what represents the inverse of addition. That's a repeat question, why it's already shaded. Question 2, root 2 minus 1 over root 2 plus 1. This is a repeat question from
2013.
2013, which is 3 minus 2, root 2.
Yeah.
All you'd have to do is multiply by the conjugate of the denominator, which is root 2 minus 1.
No, one is B, right?
Yeah, number 1 is B.
So you're making the marks or not?
Repeat?
You're making the marks, the yellow marking for the answers, or
If I'm making the mark?
no, the answers like gonna put the yellow, you always put the yellow thing on the letters.
Yeah, shaded. This time I'm using red.
Oh, okay. I don't see it, that's why I asked.
Oh, you're not seeing the red shading?
Anything.
Oh, I see what happened. Sorry about that. I'm not on the right one. You seen it now? Are you seeing the screen now?
Yes, sir. Yes, sir.
All right, sorry about that. I opened 2 files. All right. So question 2, that's a repeat from question 13. Now question 3. Now this is a new one. It says, what is the inverse of P implies Q?
D.
So D.
D.
D as in dog?
Yes, sir.
D as in dog, yes, that is the inverse of P implies Q. So let's say for this year they decide to change the question. Just to know them all, P implies Q is what? P implies Q is known as what? It's the conditional statement. P implies Q is known as the conditional statement. The conditional statement is logically equivalent to something that goes like this. Not Q implies not P. What is not Q implies not P?
Yeah, repeat.
Yeah, I was saying what is not Q implies not P.
A contradict.
Nah, this one is known as the contrapositive.
Oh yeah, positive, sorry.
Contrapositive. And the contrapositive is logically equivalent to the conditional statement. So this is known as the contrapositive. All right, so I'm just going through all 4 of them that can come. And then you have, as we just said, not P implies not Q. As Errol just said, this one is known as the inverse. This was the one they were asking for. That's the inverse statement. And then the final one is not Q, is Q The final one is Q implies P. What is Q implies P?
Converse.
Converse. Very good. Q implies P is the converse. And so these are the 4 statements that you have to know. And you have to know which 2 are the same. All right, so these 2 are logically equivalent. They're the same. And these 2 are logically equivalent. They're the same. Important stuff to remember. And so this one, as Errol had said, is D.
Number 4, maybe number 4 as well.
Yeah, that's D. Why does it keep doing this? This is question 5. It says if remainder of 7 is obtained when x cubed minus 3x plus k is divided by x minus 3, then k equals minus 11. So how did we arrive at this answer?
Using is it remaining polynomial?
Remainder theorem.
Yep, theory. Okay.
The remainder theorem states that if x minus a is a factor, if x minus a is a factor, then, or if x minus a, if a function is divided by x minus a, leave some remainder r, then f of a is equal to r. And so we said f of 3 equal to 7 in this function and solve for k. So this is also a repeat question why it's already shaded. That's 2013 repeat, and that is A. Question 5. Question 5 says what is not P and not Q? Well, you can just remove the brackets. So it's the same as just not P and not Q. So you see how that one's straightforward?
Yes, sir.
That one is clear. All right, that's a repeat as well from 2013. So you see how many repeat from 2013 already? Question 6. It says ln x raised to the y. Ln x raised to the y is just y ln x. Because logarithm, we can bring down the power. All right, and so that question.
That was a repeated question?
Yeah, this was a repeat question. This came 2013.
Oh, okay. I don't remember, but all right.
This came oh no, this came 2007. Sorry, we have looked at 2000. We have looked at 2007. It's a repeat question from 2007.
No problem.
Yeah, so ln x to the y is just y ln x. So just to write it down, just some rules of logs. Always good to remember the rules of logs. The log of a plus the log of b is what?
Now log AB.
Log AB. So that's the first one we have to remember. That's the log rule for addition. Log of a plus the log of b is the log of AB. Now what is the log of a minus the log of b?
Log of a over b.
Log of a over b. Very good. So that's the rule of differences. Log a minus log b is the log of a over b. All right? And then finally, the next rule is that the log of any number n to some power p is equal to
P log n.
p log n. P log n. So these are the 3 powerful rules of logarithm that we have to know all the time. The three powerful rules of logarithms.
Sir,
All
what
right,
about the change basis?
all right, that's one that I needed to get into. All right. Now there's also the change of base rule of logarithm, which states that, let's say we have the log of, I'm going to start with some base b and some number n. That's equal to the log of a new base. I can call that new base c of the number n divided by the log of the new base c of b, where b is the old base. All right? So that's an easy formula to remember. The log of a base of some number is equal to the log of the new base of the number of the log of the new base of the old base. Easy formula to remember. That's a change of base law. And then finally, there's one more to know, where the log of a base of a number where the number is equal to the base is equal to 1. There's also one more that you don't really have to know it because you can prove it, but I've seen they ask this in 2007. The log b of n is equal to 1 over the log of n of b. That's the inverse log rule. You don't need to know it, but it's always good to know.
Until Unit 2 or just...
Oh, no. This won't be in Unit 2, but it's just good to know because they asked the MCQ with this. They gave us log b to the n and they asked what is it equal to. We can prove why it is equal to this. That's what you had to do. But I'm just telling you in general, for example, if I give you the log to base 5 of 20, that's just equal to 1 over the log to base 20 of 5. So this is a nice rule to know so that you wouldn't have to work it out. But we can prove why that is. So if it asks in one of these papers, we'll get to prove it. So that's question 6b, as in bat. Question 7, it says if alpha and beta represent the roots of the equation, then x squared minus px plus q is equal to 0, where alpha and beta are the roots. So what is the value of alpha squared plus beta squared? All right, now x squared minus px plus q equals 0. So they gave us the equation x squared minus px plus q equals 0. And so if this equation is equal to 0 and the roots are alpha and beta, then alpha plus beta is equal to p. And then alpha beta is equal to q. That's what they're telling us from this. Now the question asks us what is alpha squared plus beta squared. Alpha squared plus beta squared is going to be equal to alpha plus beta all squared, minus 2 alpha beta. That's the formula for find alpha squared plus beta squared. Now alpha plus beta all squared, well, alpha plus beta is p, and so it becomes p squared minus 2 times alpha beta. Alpha beta is q, and so it's p squared minus 2q. And so that question is p squared minus 2q, which is C.
Afternoon, sir.
Afternoon.
What paper is this?
This is 2014.
Okay.
All right. And so that's question 7, which is cat. All right, question 8 is a repeat question. Question 8 tells us the graph of f of x is equal to the modulus of x minus 2 plus 1 is best illustrated by, tell me the answer. This is a repeat one.
Wait, what, sir?
So this question says the modulus of x minus 2 plus 1.
Here's what
Which
A,
one?
sir.
A?
Wait,
C?
can I go down?
Wait. But number 8?
What
Yeah,
is
question
modulus?
Oh, C. Wait, we did this C.
This is C?
Yes, sir.
Very good. This is C. It is true. All right. So it wanted the modulus of x minus, the modulus of x minus 2 plus 1. So just to refresh our memory, how we sketch a graph of modulus is, so let's say I give some graph right here. Y equal to x minus 2 is a line like this. That's a line of y equal to x minus 2. That's a line of y equal to x minus 2. Now the modulus is a function that flips. It flips everything that is below the x-axis over the x-axis. And so what is going to happen now is that we're just going to flip everything below the x-axis, which is from right here above the x-axis. And so then this graph is now y is equal to the modulus of x minus 2. So this graph where everything is above the x-axis is y equal to the modulus x minus 2.
Sir, but I said the answer is C, right?
Yes, it's C.
Sir, but C come off for the graph.
Repeat.
C come off for the
Yeah, so this is the critical point at 2. But
Yes,
now it
but-
asks for y equal to the modulus of x minus 2 plus 1. So this is where you have to move the graph in the positive y direction by 1.
Right, is a plus 1?
Yeah, plus 1. So move it up by 1 now. And so this is what it becomes. We'll just move it up by 1. And so that's what the graph becomes. So right here, it would have, instead of passing through minus 2, pass through 2. When you move it up by 1, it's going to pass through 3. The critical point is still 2. And so that is cat. That's it. All right, question 9 is another repeat. Let's look at it and tell me the answer for question 9.
Boy. B. Yeah, B.
B?
Yes, sir.
Yes, that is bat. Question 9 is bat. All right, and so how we have done this to make x the subject, it says if log base a of 4 plus log base a of x minus log base a of 7 equal to 2, then what is x? First, what we had to do, as we know, is use rules of logarithms to simplify the left-hand side. So we had log to base a of 4 plus log to base a of x minus log to base a of 7. It's equal to 2. So what we have to do is to rewrite all of this as one logarithm, which is log to base a of, when the bases are the same, not when the bases are the same, the sum of 2 logs is the log product, and so that becomes 4x. And then this one is a subtract, so that one go in the denominator over 7. So that is log to base a of 4x over 7 is equal to 2. And so then what we have then is that it implies that a squared is equal to 4x over 7. And so therefore, if we bring over the 7 and divide by 4, we get 7 over 4, a squared is equal to x. So that's that question for question 9. Easy, easy, soft. That's question 9. Question 10. It says, this is also a repeat question. So which one is question 10? What's the answer for question 10?
Look like A.
A.
Question 10 is A.
Yes, sir.
We sure?
Yes, sir.
We sure we're not like?
Yes.
Yeah, that's A. A is true. A is true. And so how we got A again is the sum is minus 2 over 7. And so the cubic equation, we have to always remember how we write the standard. A standard cubic equation is written as x cubed minus the sum of the roots times x squared plus the product where we're putting it as a pair of 2 roots times x minus the product of all 3 roots is equal to 0. That's the standard way to write a cubic equation. And so it is x cubed minus, now the sum of the roots as it was given was minus 2 over 7. And so minus and minus become plus 2 over 7 x squared. Then it was minus 1. And so the product by 2 of the roots was minus 1. So we get minus x. And the product by 3 was minus 3 over 7. And so minus 3 over 7 becomes plus 3 over 7. The next thing to do is to multiply this equation throughout by 7 to get rid of the fractions. So getting rid of the fractions, we get 7x cubed plus 2x squared minus 7x plus 3. So yes, you were right. You all were right. It is alpha. Alpha is the answer. Or apple. Alpha sound better since it's maths. All right. Question 11. It says, which of the following sets of ordered pair represents a function? Which of the following represents a function? So the first thing I would do is to look which one is not a function. All right. Now, first of all, what is a function? What's a function? A function is where each element in the domain maps to only one element in the codomain. That's a function. Each element in the domain maps only to one element in the codomain.
Or the one-to-one.
No, well, you can have many-to-one function and one-to-one function, but this is just the general definition of a function. It's where each element in the domain must map to only one element in the codomain. So typical examples as you just mentioned, a one-to-one function, you can have A, B, C. Each element in the domain is going to have to map to one thing. So it can map to 1, B map to 2, C map to 3. Now this would be known as a one-to-one function. That's a function. Now here we can have A, B, C, and over here we only have 1 and 2. A map to 1, B map to 1, and C map to 2. Is this a function?
Yes, sir.
Yes, it is a function. This is a many-to-one function. Many-to-one. All right. Now look at this now. Let's say we have A, B, C, and it's being mapped to, let's say it's mapped to 2 and 4. And let's say A is mapped to 2, A is mapped to 4, B is mapped to 2, C is mapped to 4. Is this a function?
No, sir.
Why is
No,
it
sir.
not a function?
That's one to many.
One to many. That's why it's not a function. So this one is not a function because it's one to many. And so you're looking for a case where you're going to see one to many. All right. So in this question, you just want to look for any case where you have one to many. All right. And so look at option B. Look clearly at option B, right? In the domain and the codomain, the domain we have -2, 1, 1, and 2. So write it down. -2, 1, 1, and 2. Now look at this. 1 is mapped to 1 and 1 is mapped to 4. Can we see that? In option 2, look at option 2. 1 is mapped to 1 and 1 is mapped to 4. So what is that? One to many, right? Can we see it?
Yes, sir.
Yes. So right here in option 2, we have 1 mapped to 1 and 1 mapped to 4. So this is a one to many. One to many. Option 2. And so therefore the question is already complete. If option 2 is one to many, then A is out, B is out, and C is out. And so the only option is D. Because option 2 has to be out. Because option 2 is not a function. All right, because that's a one to many relation. That's clear? That's clear?
Yes, sir.
All right. Question 12. Question 12 is A to the fourth minus B to the fourth. So let's work that out. Now A to the fourth minus B to the fourth, we can write it as a difference of 2 squared. We have A to the fourth minus B to the fourth. That is equal to A squared.
A squared plus B squared times A squared minus B squared.
Very good. It's equal to A squared plus B squared. And that's because we use the difference of 2 squares. Because we can rewrite A to the fourth and B to the fourth as that. So now we write it as A squared plus B squared. A squared plus B squared times A squared minus B squared. Now A squared minus B squared can be simplified further, right? We can simplify this side further to get A squared plus B squared. A squared plus B squared. Now this part that is saying A squared minus B squared, we can write it further as A plus B times A minus B. Right? So we can simplify it to this way. All right. So now look at this. This is a to the fourth minus b to the fourth. If we multiply it by, let's say we're going to, there are two possible answers there could be. All right. The first possible answer is if we multiply a squared plus b squared by a minus b. And then we can also multiply a squared plus b squared times a plus b. So let's do it this way first. We're underline the red. So multiplying out those would give me a cube minus a squared b minus a squared b. Then I'm getting plus ab squared minus b cube times a plus b. We agree with that? Agreed?
Yeah, man.
All right. Now, another way they could write it, because we have to look at it two ways, because they can always write it as a plus b times whatever left, or they can write it as a minus b times whatever left. And so we have to look at it from two ways. So now the other way is a squared times a, that's a cube, plus a squared times b, that's plus a squared b, plus b squared times a is ab squared plus b cube. So there are two possible ways the answer can be written. It can be written this way, or it can be written this way. And so we have to look at the options that are given to see which one of these two are there.
I'm back.
So let's look at this now. So a minus b. So it's not the ones. It's not the ones it did.
One says
Repeat.
D.
It's which one?
Dog.
Dog
E. Yeah.
is minus a squared. Let's look back. Minus a squared b. Yes, dog is the answer. So you see what they did right there. So this question is a repeat question, but 1 year they had the solution being with a minus b, and now in this year they're having the solution to be with a plus b. So it's just how you go about factorizing it. So that's dog. All right. Question 13. What's question 13? 5. This is a repeat. Yeah. Big repeat question. This is 5. All you have to do to get this question is use change of base law in the power. So just to refresh our memory, log 3, 5. Right, so we have 3 to the log 3, 5. We can use change of base law in the numerator to get 3 to the log 3, 5 is the same as change it to base 10, which is log 5 over log 3, where the base is 10. And so when you put in your calculator log 5 divided by log 3, you're going to get 1 point something. Log 5 divided by log 3 is 1.46. So it's 3 to the 1.46, which is 5. So that's how we actually work that one. But nice to see that we've all remembered. Very good. So we're looking very good for CAPE 2020. Because we know that it's going to repeat. Question 14. This is a repeat from 2011. What's question 14?
B.
Question 14 is?
B. C. Sorry, C.
Oh, I was just shocked. This is cat. All right. And so that's why sometimes it's not good to go straight off memory. You can actually just work it back out. So it is cat.
I got distracted, that's it.
Repeat.
I got distracted, I was looking at something else.
Okay, that's fine. So that's C. So how we go about doing it is by factorizing x minus p. So we have x minus, just to refresh your memory how we did it, x minus p cubed minus q squared times x minus p equals 0. And so what we actually did was factorize out x minus p. We factored x minus p, and what we're left with inside is x minus p all square minus q square. And then if we have the product of two numbers being equal to 0, then one of the numbers must be 0. And so we're solving either x minus p equal to 0. Let's continue it right here. So when we're solving x minus p equal to 0, what we're getting is x is equal to p. So this one gives x equal to p. And then solving the second part now, where we're solving x minus p all square minus q square equal to 0. When we're solving that part now, we end up solving the difference of 2 square, which is x minus p minus q equal to 0. And then we're solving or x minus p plus q equal to 0. And these will give the solution of p plus q and p minus q. So that's that, which is cat. Okay, question 15. Question 15 is also a repeat question. It says the table below shows the values for the functions f and g. What's the value of g inverse of f of 3?
5.
5. Very good. And just to refresh our memory, first we find f of 3. So when x is 3, f of x is 2. And so therefore f of 3 equal 2. And so we want g inverse of 2. Just to point this out again, when you're finding g inverse of 2 using the table, g inverse of 2,
When g of x equals 2.
yes, you're solving when g of x is equal to 2. That's what that means. And so what is the value of x? That is going to give g of x being equal to 2. That's what this means. What value of x give us g of x equal to 2, and that's 5. That's cat. Question 16. Repeat. What's this? The center of the circle.
1 and 2, D.
1 and 2.
1 and 2. Very good. Dog. Let's use mathematics symbols from now on. D as in delta.
A.
D as in delta. So
Okay.
using mathematical symbols. We'll say alpha, beta. What we can say for C?
Cos.
Just say Kramer.
Kramer. That's cool. Yeah, we can say Kramer.
What's Kramer?
So when you do unit 2, you're going to learn about Kramer's rule. It's another way to solve simultaneous equations.
Okay, sir.
So that's D. So we're going to say alpha, beta, Kramer, and delta. It all sounds good. It sounds good. It sounds like music to my ears. That's good. Question 17. What's 17? This is a repeat.
Beta.
Beta. Beautiful. Beautiful. Beta. So just to refresh our memory, it's just the expansion of cosine, right? Where this is just going to be cosine pi by 2 times the cos of p plus the sine of pi by 2 times the sine of p. But the cos of pi by 2 is 0, and so we get 0 plus sine p. So that's beta. Question 18.
Delta, we also repeat as well.
Delta also repeat. So we can see that this year, 2014, I was so lucky because everything repeated. That is delta. Where is it? Oh, so why did it change the color? For some reason, it changed the color. Yeah, I want to go back to the red. That's delta. Question 19. This is also a repeat. It's the sum of Kramer.
Yes, sir.
Yes,
C.
the sum of two signs. The sum of two signs is Kramer. All right, so just to refresh our memory of the sum of two signs, sine A plus sine B.
2 sine A plus B over 2 cosine A minus B over 2.
Very good. So it's twice the sine of half the sum times the cosine of half the difference. So the sum is A plus B. So twice the sine of half the sum times the cosine of half the difference. I've been using that for many years now to remember it. It's easy to remember. Sum of two sines, twice the sine of half the sum times the cosine of half the difference. And in this case, A is 6 theta. In this case, A is equal to 6 theta and B is equal to 4 theta. And so what we get is 6 theta plus 4 theta divided by 2 is 5 theta. And 6 theta minus 4 theta over 2 is just theta. And so as you rightfully said, it is Kramer. It is Kramer. All right, yes, I will do so. Don't worry about it. All right, that's question 19. Now we're at question 20. That's 24. Where's question 20? Can we see question 20?
Boy.
It says, which of the following, repeat?
Beta.
Boy.
Beta, not boy, beta. Beta, so this is a repeat question, right? And I showed you how to check this graph too. How we check this graph was, look at cosine of 0. When x is 0, you're gonna get 1. Then put in when x is pi. When x is pi, you're gonna have the cosine of pi by 2, which is 0. And then put in 2 pi. The cosine of 2 pi divided by 2 is minus 1. So this is the only graph that satisfies those conditions. So all the other graphs are incorrect. So that's beta. Question 21. What's question 21?
Kramer.
Kramer. Nice. So just to refresh our memory, how is it Kramer?
Pi by 3.
It is pi by 3. And how did we solve this question?
So you can solve it like a trig equation.
Trig equation. Very good. So we had to factorize. So we have, just to refresh our memory, 2 cos cube. 2, was it cos cube or cos square?
Square.
Cos square. So 2 cos square theta minus, was it minus? Why am I not remembering? Plus 3 cos theta minus 2. Plus 3 cos theta minus 2. And so we solve it like a trig equation because it is a trig equation. And so we use factorization principle. So factorize it, set it equal to 0. If it's 2 right here, then the two numbers has to be 2 and 1. Then this now has to be 2 cos theta, and this has to be cos theta in order for us to get cos square theta. So this is cos theta. Now, how are we going to get plus right here? To get plus right here has to be plus. This has to be minus. So that's how we factorize it. But this part is going to be invalid. This part is not valid. Why is that part not valid?
The cosine of an angle does not exceed 1.
It does not exceed 1. It has to be between 1 and minus 1. Very good. And so we're solving this part. First, we're solving 2 cos theta minus 1 being equal to 0. And so what we're actually solving is the cos of theta equal to 1/2. If the cos of theta is equal to 1/2, then theta is equal to pi by 3. Theta is equal to 60 degrees, or as some would put it, pi by 3. That's question 21. Yes, Errol, go ahead and speak.
No, accident, sir.
Okay. All right, question 22. What's question 22? This is a repeat as well.
Alpha.
Alpha times it by minus 2. Yes, it is alpha. There's also an easy way to do this question. The easy way to do it is the general equation is going to be x squared plus y squared plus 2ax plus 2by plus a constant equals 0. That's the general equation. Now, how you know the general equation is right here is you're going to multiply the minus 3 by negative 2. You multiply it by negative 2, you're going to get positive 6x. Then you multiply the 5 by negative 2 to get minus 10y. And this is the only question with this is the only answer that is going to be valid. Let me tell you why. If this is positive 61 right here, when you bring it over, you're getting negative 61. But the sum of positive numbers is not going to give you a negative number. So the only possible answer is A. That's using logic. But let's say you want to work it out. So as I was saying, from the general equation, you would divide these two numbers right here. So remember how I said you find the center? You find the center by dividing these two numbers by what? Negative 2, right? Agreed?
Mm-hmm. Yes, sir.
Yeah, we'll find the center by dividing these two numbers by negative 2. And likewise, we can also find back, given the center, you can then find these two numbers by multiplying these two by negative 2. But let's say you wanted to work it out. So working it out, we have the center being minus 3 and 5, and the radius is equal to 6. And so the equation of the circle is x plus 3 square plus what?
Y minus 5 all squared.
Y minus 5 all square.
Yeah.
That's equal to
36.
equal to 36.
X squared. Okay.
And so all we do is expand right here to get x squared plus 6x plus 9 plus y squared minus 10y plus 25 plus 25, and that's equal to 36. So bring over the 36 by grouping all the constants. So group all the constants, 9 and 25, that's 34. 34 minus 36. So that the constant part is working out to be 34 minus 36, which is negative 2. I'm only working out the constant part because this part is clear. We're going to have x squared plus 6x plus y squared minus 10y. So that goes down here. X squared plus y squared plus 6x minus 10y. That is alpha. Question 23. This is a repeat. What's 23?
Delta.
Down.
Delta. Very good. Delta. So all we had to do was make t the subject from any one of them and then substitute into the other equation. So let's say we wanted to do it. Just to refresh our memory, x is equal to 3 plus 2t, and they said y is equal to 1 over t. We can use x and make t the subject. So right here we get x minus 3 over 2 is equal to t. And so we can plug t into this equation. And so what we get now is y is equal to 1 over t. So y is equal to 1 divided by all of this right here, which is x minus 3 over 2. And so we get 2 over x minus 3. So y is equal to 2 over x minus 3. Easy stuff, soft, a capital T. That's question 23. All right, question 24. That's a repeat. What's question 24?
Alpha.
Alpha, very good. It is alpha. Let's say we're working this out back again. Again, just to refresh our memory, sine square plus cos square is 1. And so right here, we can factor out 2 to get 2 times sine square plus cos square, which is just 2. And then sec square minus tan square. Well, first and foremost, tan square is sec square plus 1. And so we have sec square minus, and it works out to just, all of this is going to work out to be 1. And so we have 2 times 1. So let's just write it down for those that are not seeing what we're saying. P is equal to, we can factor out the 2 to get 2 times sine square plus cos square times sec square minus tan square. Sec square minus tan square. First and foremost now, we have to recall the identity that sec square is equal to 1 plus tan square. Sec square is equal to 1 plus tan square. So this works out to be 2 times 1 times sec square is 1 plus tan square. And so we get 1 plus tan square minus tan square. And that's how we get 2. Easy, easy, easy question. Soft. So that is alpha. Question 25. Repeat question. What's 25?
Kramer.
Question 25 is what?
C. Oh, it's 25. So my bad. Oh yeah, alpha. Sorry.
Alpha.
I was looking at 26.
Okay. So remember, it has to be alpha. And the reason why it has to be alpha is because when you're expanding this, it is a sine of alpha plus the cosine of pi by 4. And the cosine of pi by 4 is 1 over root 2. This is the only one with that option. So that's alpha. It cannot be beta because when you expand the compound angle for a positive sign, you're not going to get minus. So B and C out. Dog is out because it cannot be half. The only thing that's associated with half is if it was pi by 6, sine 30. And so therefore dog is out. It has to be A, alpha. 26. 26 is a repeat question. What's 26?
Kramer.
You sure?
Yes, sir.
All right. So it says, yes, Kramer is right. And it says the variable P moves so that it has the same distance from 1, 6 and 3, 2. So you can call 1, 6 A and call 3, 2 B. And so what they're telling us then is that they're telling us that PA is equal to PB. If PA is equal to PB, then we can find the distance of PA, which is this right here, and the distance of PB is this right here. And so therefore, this is correct. That's correct. Now these are giving something with gradient, which has nothing to do with this question. So anybody put A and B, that's awful. If you put D, I'd understand, but it has to be C. All right, question 27. This is a repeat. What's 27?
Alpha.
Alpha. Very good. All right, so to do question 27, first you'd have to work out what is 3 times A, which is 3 times minus 3 times 7, plus 2 times 2 minus 1. And what you'd get is minus 9. Minus 9 plus 4 is minus 5. And then you would get 21 minus 2, which is 19. And so the modulus of this thing right here, because this is now 3A plus 2B. Now the modulus of that thing is 5 squared plus 19 squared all square rooted. 5 squared plus 19 squared square rooted. And that's what we get. 5 squared plus 19 squared square rooted is the square root of 386. Agreed?
Yes, sir. We
All
also
right,
repeat back on 2019 paper.
Repeat.
A question repeat back on 2019.
All right, so you know that there's a good chance it's going to repeat on 2020. Question 28. It says a circle has minus 1, minus 1, and the equation of the tangent to the circle at the point 0, minus 3. So you can always draw one little circle What's the answer? Because this is a repeat.
Beta.
Yes,
I'm right.
beta is the answer. Yeah. So draw the circle, put a point, and draw a tangent to the circle. And one equation of the tangent. But to find the equation of the tangent, we first need the gradient of the tangent. But we can find the gradient of the normal, because we know the normal passes through the center and the point of tangency. And so the gradient of the normal is y2 minus y1, which is negative 2 over x2 minus x1. Minus 2 over 1, which is minus 2. And so if the gradient of the normal is minus 2, and the gradient of the tangent is a half. And so since the gradient of the tangent is a half, well, look which one have a half, which is beta. Easy, soft. Question 29. Repeat question. What's question 29?
29.
13. Cat.
Yeah. C.
Cat. Very good. All right. Question 13 is cat. There are 3 ways, as I said, you can do this question. 3 ways. Well, the maximum point of D, this is a new method. I didn't show this one. You could say the maximum of D is D modulus. D modulus is A squared plus B squared. So it's 12 cos theta plus 5 sine theta all square. Square rooted. Yeah, that one is complicated. You'd have to do unit 2 to do what I was about to show you. But using the unit 1 method, we say D max is, we can write it in the R sine form or the R cosine form. It's going to be A squared plus B squared all square rooted, which is 13 times the cosine of theta minus alpha. And so the maximum value is going to be R, which is 13. So that's the unit 1 method. Using a calculus method, we could differentiate. Question 30. What's question 30?
Cat.
Karma.
Repeat.
Cat.
Karma.
Kramer. Very good. So it says a unit vector. Once them say unit vector is always in this form. A unit vector u is equal to 1 over the modulus of u times vector u. That's a unit vector. The only one in this form is Kramer. So you don't even need to work it out. So that's question 30. Easy, easy, soft, with a capital T. Question 31. Question 31 says, which of the following is true? Is f prime of 1 less than 0? Is f prime of 1 less than 0?
Of 1.
Is f prime of 1 less than 0?
No.
Yes, it is. F prime of 1 is less than 0. F prime of 1 is negative. How do I know it is negative? Right here, the function is decreasing. So when x, so for all x being less than 2, f prime of x is less than 0. F prime of x is the gradient. For all x being less than 2. So everywhere over here, the gradient is negative. So remember when we talk about gradient, when it look like this, gradient decreasing, this means the gradient is negative, it's a minus gradient. When it looks like this, positive gradient, and then when it's just a straight line like this, the gradient is 0. Agreed? We agree with that?
Yes, sir. Yes, sir.
And so therefore, f prime of 1 right here is negative. The gradient is negative. The next question it says is f of 1 greater than k?
Yes.
Yes, right here. F of 1 is greater than k. This is f of 1 right here. F of 1. All right, f1. f1 is greater than k. It says f of 2 equals 0. Is that true?
No.
No, f of 2 is equal to k. So this
K.
out. Then it says f prime of 2 equal k.
No.
No. What is f prime of 2?
The prime of 2, it's increasing, sir.
F prime of 2 is going to be 0 because right here is the
0.
turning point or the stationary point.
Well,
So this is out as well. And so the answer is going to be the one that has I and II, and that looks like alpha.
alpha.
All right, so now this
And what was
question is
number 26?
question 26. All right, let's go back to question 26. Question 26 was Kramer. That was 26. You get that?
Ah,
All right. So now back to right here. This question right here, I have a strong feeling this is going to repeat. But look at this. This question has repeated many different ways. Meaning, sometimes you see them write f of 1 is less than 0. And next time they might write f prime of 1 is greater than k. And next time they might write f prime of 2 equals 0. So all I'm saying is they like to change the options right here when they repeat this question, all right? So be very careful with this question in particular when they repeat it. Can be troublesome. All right? Question 32. It says find the limit as x approaches -5 of
The answer looks like
plus
A.
5. What is it?
It looks like A, sir.
It looks like alpha. Let's check it out. X plus 5 over x squared can be written as x minus 5 times x plus 5. The x plus 5 part is going to cancel.
answer C, sir.
Oh boy.
We get 1 over x minus 5. And then we're going to plug in x
And
is
I
-5.
never realized the negative sign.
And so it's 1 over -5
-5
minus 5,
minus 5
which is 1 over
minus
-10.
110.
That's a -5.
Yeah, this is a minus.
I never realized it was -5. That's right.
Okay, so it is beta. So let me zoom in to show it's -5. It's -5. That's beta. Question 33. What's question 33?
Apple.
Apple. Very good. So we just have to remember this formula.
Hello, can you hear me?
Yes, can hear you.
Oh, okay.
F prime of x, any function, the first derivative is equal to the limit as h goes to 0 of f of x plus h, f of x plus h minus f of x over h. That's the definition of a derivative. And so therefore, in this case, f prime of r is going to be equal to the limit as x goes to h, as h goes to 0 rather, of, in this case, f of r is pi r squared. Let me just write that down. F of r is pi r squared. And so this is going to work out to be the limit of f of x plus h is going to be pi times r plus h squared minus pi times r squared over h, which is alpha. So alpha is indeed the answer. Indeed, alpha. Very good.
This is the
Question 34. So we want dy by dx. To find dy by dx, we need the first derivative of x and y. And so the first derivative of y, we can call it y prime. Y prime is going to be equal to t squared plus 2, which is 2t plus 2. And then x prime is going to be equal to 2t minus 2. And so now we just have to remember that dy by dx is equal to dy by dt times dt dx. Times dt dx. And dt dx is just 1 over dx dt. And so this works out to be 2t plus 2 over 2t minus 2. 2t plus 2 over 2t minus 2. And so what's the answer?
Beta.
Repeat.
Beta.
Beta. Beta is the answer. We can factorize out 2. Very good. All right. Now question 35. Question 35 is a repeat from a Unit 2 paper for 2013. So they take off this question of a Unit 2 paper.
Oh, that's delta.
This is delta.
Delta.
Delta. All right, so just to refresh our memory, how we got delta is just to remember how we integrate cosine. So now cos 2x, we have to remember cos 2x is equal to cos square x, 2 cos square x minus 1. That's cosine 2x. And so if I were to call this x now x over a, and so therefore the cosine of 2 times, let that x small, that small x be now x over 4 is equal to 2 times cos square x over 4 minus 1. And so what we can do now, well, 2 times x over 4 is cos of x over 2, and we can bring over the 1 to get the cosine of x over 2 plus 1 is equal to 2 times cos square, 2 times cos square x over 4. And so the integral of this side is equal to the integral of this side. And then we can divide by 2. And so what we're getting now is, let's just take out the 2 now. We can take out this 2. and put it as a half over here. And so it works out to be a half times the integral of cosine x over 2. The integral of cosine x over 2, when you differentiate cos, when you differentiate sine, you get cos, and so the integral of cos is sine. But they didn't want that. Sorry. They wanted you to stop right here. I believe this is where they wanted us to stop. A half of the integral of cosine x over 2 plus 1. That's where they wanted us to stop. But then now we just have to remember that when you integrate the 1, you get x, and then x times a half is a half. That's how we get delta. That's 35. Easy question. Soft. Question 36. What's question 36?
Kramer. Kramer.
Kramer, very good. That's easy. So only thing we're looking at right here is 3x over x. Imagine the x's cancel, let us get 3.
Or the identity that equal to 1, just times it.
Repeat.
I think the identity for the lim sine x over x equal to 1.
Yes, that's the rule. Like the limit as x approaches 0 of sine x over x is 1. And so we can write this as a limit as x approaches 0 of sine 3x over 3x. But remember, this had an x alone. So if we put 3 right here, we have to go put a 3 in the numerator. And then the limit of sine 3x over 3x is 1. And so it works out to be 3 times 1, which is 3. So that's how we get C. Easy stuff. Question 37 is a repeat. What's question 37?
Delta.
Delta.
Dog.
Nice, delta. That's question 37. Question 37 is delta. All right. That's a repeat one. This is repeated so many times. So that's, we can use either quotient rule or product rule to do that question. Question 38 now. Question 38, you have dy by dx is 2xy, then find d2y by dx squared. This is also a unit 2 question repeat. And the reason why it's a unit 2 question is in unit 1, you do not know how to do implicit differentiation, but there's a little bit of implicit differentiation right here. Because to find the second derivative is d2y by dx squared. You use product rule. So you keep the first and differentiate the second. So when you keep the first is, you keep 2x, so that's your u, times dv. When you differentiate y, you get dy dx. Plus, you keep the second y, then you differentiate the first, and you differentiate 2x, you get 2. And so d2y by dx squared is equal to 2x, but it's at the point 1, 2. And so it is 2 times x, when x is 1, times dy by dx. Now dy by dx is 2xy, and so it is 2 times x times y. That is 2 times 1 times 2 plus 2y plus 2y. Y is 2, and so that's 4. And so it works out to be 2 times 2 times 2, which is 8. 8 plus 4 is 12.
Yeah.
So this is a unit 2 question. They took this off a unit 2 paper. I believe they took it off 2008 unit 2 paper. So they like to do that sometimes because in unit 1, what you learn in module 3 is pretty much the same in module 1 in unit 2. So they like to do that. They like to take questions off Unit 2 paper and put on Unit 1. That's when they think they've repeated too many questions. So now they say the gradient at x is pi by 6. The gradient at pi by 6 on the curve y equals sine x. So if y is sine x, we need to first find dy dx. And so dy dx is cosine x. And so what's the cosine of pi by 6?
Cosine of 30. That is root 3 over 2.
Root 3 over 2, which is
Yeah?
delta.
Yeah, I never heard, sorry.
Yeah, that's fine. So that's delta. That's 39. All right. Now question 40. This is a repeat. What's question 40?
Alpha? Yeah, alpha.
Question 40 is alpha.
We did
So
this
now
last
question 40, right? Just to go through this question again, it says water is leaking from a tank, right? And so since they're talking as water is leaking, then the volume is decreasing. So we have minus V. And they say the rate of change in the volume of water in the tank with respect to time is inversely proportional to its volume. And so they're telling us that dV by dt is inversely proportional to this negative volume. So it's inversely proportional to 1 over V. And so therefore dV dt is equal to the constant of proportionality, which is K over V. And it is minus K, because K times minus 1. That's alpha. Question 41. Now this question can be tricky because you have to look out for when they say volume around x-axis or volume around y-axis. This is x-axis. Volume around x-axis is pi times the integral of pi squared dx. That's volume around x-axis. So what's the answer for this one?
for 41.
Yeah.
Beta.
It is
Beta.
Beta.
beta. Because when you make y squared the subject right here, you get y squared is 4 minus x squared. And so it is beta. Easy question, soft. Question 42, based on the diagram, which of the following statement is not correct?
Beta.
Boy.
Beta is not correct? You sure about that?
Yes, sir.
That is true, because the limit does not exist. So if the limit does not exist, then the limit can't equal to the functional value. The functional value at this point is also undefined. So beta is not true. Question 43. This is also a repeat question. So what's question 43?
Kramer.
Kramer, it's 4. So all you have to do is that since it is continuous, they said given that f of x is continuous at x equal to 3, then that means that f of 3 times 3 plus 5, and it's equal to a times 3 plus 2. So bring over this 2 over here to get 12 is equal to 3a, and so a must equal 4.
Yeah, that's right. Oh, that's why I did it.
Yeah, easy question. That's 43. Soft. Question 44. What is that? That's
Delta.
x cubed. So you said delta. You agree with him?
I
Yes,
guess.
delta is correct. Let's work it out. So the numerator would become x minus 2 over x squared plus 2x plus 4. Agree?
Yeah, I did it.
That's how we factorize the numerator. And then it's being divided by x minus 2. And so the x minus 2 cancels the x minus 2 right here. And then we'll plug in the plug in 2 now. Plug in 2, we get 2 squared plus 2 times 2. 2 squared plus 2 times 2 plus 4. So adding 4 3 times,
Yes.
which is to
4
get
times
to
2
12.
Okay.
I'll get 12. All right. Now right here we have x cubed times sine x, right? X cubed times sine x. So it asks for the differential, the first derivative of x cubed times sine x. This is a repeat question. What is this?
Delta.
Delta. Very good. It is delta. So it is how we differentiate this now. Remember, this is your u and this is your v. So it's u dv plus v du. So it's u dv, which is u dv u cube cosine x plus v du. V du is 3x squared sine x. So all you have to do now is factorize out x squared. So factor out x squared to get delta. That's 2014. Easy, soft. You can start 2015 now. That's 2014. Delta. Easy, easy, easy. All right. So I just want to hear some feedbacks. Generally, how are we feeling for exam coming up?
I don't know. It's okay, I guess.
Feeling okay. Feeling better than if you were to do the paper 2, right?
Yes, sir.